So, good morning, everyone. So, what we wanted, Getty asked me and Steve to talk with you about kind of how the discussions began that led to Getty saying, you know what, F it, I'm making a conference. So, as most great, well, before we get into that, I want to. So this is my what was it, the Getty tender for security for InfoSec. Right, so I do enterprise security architecture, large-scale systems design, implementation. I have supported DoD for quite a bit of time in the past, and commercial customers most of the time. I do systems. I can help out with systems engineering and processes, mentoring, and building out SOCs and stuff I need. Agile engineering and integration processes, and always looking for additional mentors.
So this is mine. Steve Orrin. I'm the Federal Chief Technologist for Intel. Stuff I do is government security and architecture, anti-tamper, hardware root of trust, embedded security, cloud, all the things the government cares about these days. What I can share is reference architectures, enterprise architectures, and what I find most useful, folks, is understanding the government use cases requirements in terms that you can then go to build against. I can share activities I've been doing in authentication, system security, and I can give good Scotch recommendations. I'm always looking for good Scotch recommendations, as you'll see in a moment. But the other things I need are solutions that are deployable at scale. One of the things that a lot of companies, both small and large, tend to forget is how do you actually deploy this thing in real world? And then more insight into the vectors and the actors, not just the vulnerability, but what's behind it, what are the motivations. We've talked about this. So, and I always want good Scotch recommendations.
So, as most great things, this started in the bar. This is actually a picture of the bar. This is it was Friday at the last DEF CON, the one just recent, and we all just as you do at DEF CON, wander around until you find a group of people that you know or you find interesting, and you start talking and drinking. So 7.5 hours later of drinking. And I believe you were drinking Macallan 18,
yep.
And I was drinking doubles of Booker's, and lots of other folks were consuming. So Steve Mancini was there, Toby Kleinberg, Gaddy, myself, and then several others wandered in and out over the course of the 7 hours. And this is a representative bar tab. It would have been close to this amount. It was copious amounts of alcohol were consumed. So whenever we were talking, we started coming, it was kind of the, hi, how you doing, how's work going, and then we started griping about all the problems and different things that we have seen in the presentations today and yesterday. And it really got to the point of, well, how do we fix this and what do we do? So the problem, and by the way, we started taking notes, so taking drunk notes and then trying to decipher, then type them up the next day with the hangover, that was a good challenge. And
bearing in mind that this is for all of you for future reference, if you are going to have the drunk conversation, having the notes is better than not having the notes.
This is true. This is true. So the problem that we came up with is information security doesn't have a discipline in the same way that other engineering domains do. And our solution is to create measured consistency and completeness to manifest discipline to bridge security architecture and engineering. It's pretty good for that much alcohol, right? So we decided the model we use to view security was questionable. We came up with a new idea to use the model of the RFC as a template to list the qualities of the models that we want to develop. Need a new way of looking at things where we look at discipline. So the guidelines that we kind of came up with, we've heard this one at least twice. It's a taxonomy. We need a common lexicon and a way to communicate with each other and with our stakeholders. So then we wanted interdomains, look beyond computer security, use analogies and frameworks from other industries. Gaddy was just talking about this as well. Derivative value, the model must be useful. I love the boxes, which was actually in another presentation that George Box, all models are wrong, some models are useful. Let's make these useful. If they're not, let's evolve them until they are. So one of the reasons why we're talking about some of these things is because when we go off into our groups, these are some of the thought processes that we have of about how can we judge whether we have done something useful. So consistent level point of view of abstraction. We need a consistent point of view. Normally our point of view changes based upon who we're talking to or the recipient of the information. We need a view or a set of views that's standard and documented in a common way. Having multiple documents that describe the exact same thing in different language or a different standard way of communicating, all it does is burn time because we don't necessarily have a way to communicate very well.
And I think this was brought up in your talk yesterday as well. This notion of if we're talking about the same problem but at different levels of abstractions, we're going to continue to talk past each other. It's coming up with what are those atomics, what are those fundamental building blocks that we can then agree on as the starting point to build out the model is just as important as having a common language. Because if I'm talking about the support of something and you're talking about what rides on top of it, we're both describing the same thing, but we're not getting anywhere. And so we need to figure out what are those fundamental abstractions and agree on them.
So the abstractions we use because things get complicated, we want to make them simpler. But we need to, as you talked about the atomics, we need to figure out a way to moor ourselves into something that is common. So models have to be rigorous, consistent, have consistency, be practical, and have broad applications. Some of the models will have exceptions, obviously. So we came up with two models, and there is the state and time model, which describes the robustness of the bridge and those types of attributes that describe how the bridge is built, the types of qualities. In the systems engineering world, we call these ilities. And then there's the life cycle model, which is using and maintaining the bridge. So the state and time model, interactions and components, it's called a time slice. It's a vertical thinking, it's in snapshots in time. Time slice attributes called atomics. And each of the interactions and components, the only thing that matters is the state of the interface. It's the what, not how and how the interface is used. Characteristics of the state are qualities of the asset at a moment in time. And then the asset's interactions are core to the model. So it's not necessarily about the overall system and looking at an abstract level. It's looking at each of the components of the system and seeing how they interact to have the emergent properties of a bridge. So it can be viewed as a function of risk, trust, and asset. Notice we don't bring the attacker or the user into this because you have to look at it devoid from any of those types of interactions because you are describing the system itself. So I'm going to skip some of these for the sake of time. And then there's the life cycle model.
Yeah, which is basically a series of time slices with a common context or a story, if you will. And so looking at it in a temporal view, it's a way to describe that life cycle is really a series of states. And so it's coming at it from a completely different angle. And you make decision changes based on the context. And again, the context is based on timelines. So it's recursive. Decisions are answers to messy problems. And in this context, answers tend to be recursively define the question, which can be problematic. But there's a lot of value in this horizontal thinking. And so the question, especially when you start to try to take it, go after complex problems. So what we did, and this is the problem, is we spent, 2.5 hours arguing about which model was right. And what actually came out of that, after we got tired of talking about that for a minute, is that we're both right, we're both wrong. And the reason we wanted to talk about not just the different models that led to it, instead of giving you the answers, that this is the conversation that each of the groups needs to have today.
Swallow the mic.
Sorry, what each of the groups have to think about today as they're working through their exercise is talk through the things that even if they're not the right one, but the process is going to get you to the right answer. And so what we came up with is a combination of the two models, because both are useful to describe the system depending on what your goal is. And so being able to get to a consistent engineering discipline for cybersecurity, you need to take the best of both worlds. So talk a little bit about the combined story here.
So the idea is that the life cycle and story that goes over the top, that's our second model, right? But it describes the system in its usage state, which in some ways is what a lot of us can care about. But others want to care about this vertical thinking, right? The state and time. And acknowledging which point that we're looking at and noting that they both have value and about how they interact, it lends us to be able to have better communication over the course of time. So if you look at the vertical pieces, you've got state and context. There's an atomic model of the interactions of the individual components during that time to make up the system. And then you have assets and the interactions, right? So you can talk about, at a specific point in time, this actor and this user or these specific things in this time slice interact with a system in a very specific state. And a system in a state is described by the atomics and their specific state, and it's an aggregate of those. So when you start to break down the problem like this, but can have a map of where the abstractions are, it rapidly allows communication to occur.
The other thing important to note is, and we put it in there sort of just to highlight, the beneficial and malicious. But really, from the model's perspective, it doesn't matter. They're interactions with the asset. Whether they're legitimate or it's an attacker, shouldn't change the model. The model should be independent of how your interactions are happening. Same thing with the asset. It's the target today. Tomorrow, it's the email server you all use. It's the kind of interactions you qualify the interactions, but at the end of the day, they're still just interactions. And if you treat them that way, the model can hold up. The other thing that's really important about why you don't want to just focus in on a vertical only is because the life cycle allows you to do things like forensics, allows you to do root cause. So you look at what happened, and you look at what happened at multiple states, and then you use the life cycle approach to that to be able to get the correlation. And so that's why they have to work together, and you can't just have one or the other. Because it's the old adage of having forest and trees. Some people see the forest, some people see the trees, but the reality of the story is the forest is made up of trees. So let's go to the pretty picture.
Before we go to the next picture, this is not something that is done, right? This is something that is still evolving. And the important thing to remember is that when we're having these discussions, it's not necessarily about getting to an answer. It's about asking better questions and realizing where we break down and what additional things that we need to work on. So this is a model that I pulled together, and this was part of my master's thesis. This took a lot of time to get a model that was functional, just in concept. That's not what we're necessarily asking for today, but I'm going to show this and then the executable model to show that you could eventually migrate these concepts and these solutions to model thinking. Because when we have model thinking, all of us get on the same page much faster, and then we can create simulations, and then we can test our theories in a way that is consistent, and we can also convey that to the operators and to fellow researchers as well. So I'm not going to get into explaining this. If you want to know more about it, please come see me. And then this is the same model, but this was done in VenSim. And it's about being able to execute that model. And the whole idea, it was a model for cyber conflict with you had the attackers and the defenders that were related symbiotically by the entire population of the internet based upon compromised and non-compromised hosts. So it's a way to talk about that conflict that Gaddy was talking about. And it was a way to model that. So the idea is that it's going to take a lot of thought. It's going to take a lot of time. We're not necessarily always going to be correct, but if we keep chipping away at it, this is hard work. And I think that that's one of the things that separates attack and defense is that defense is long work for small gains. And then you have these evolutionary breakthroughs.
And I think one of the things that we like about the notion of this kind of model is it allows you to describe events in a common way across multiple types of events. So whether we're talking about DDoS, which I know was one of the ones people wanted to talk about, or we're talking about a application layer attack or a whole campaign, a network-based threat versus a USB-based threat, the model shouldn't have to change for the kind of interaction. So we need to have a common way of describing those events that works across the different domains and across within cybersecurity, but also when you start looking at policy or other areas, it should go to those other domains and still have the same construct. And again, that's sort of things we want to get to. We don't have to answer it, but we have to think about that's the end game and use that as the mechanism for determining the model and determining the atomics for that model.
All right.
Thank you.
A couple of notes on this, and then we have 5 minutes to discuss what we're going to do after lunch, and we're breaking for lunch. So, very quickly, going back to this. During the 7.5-hour discussion where we had a tab of, I don't know, $10,000 in drinks, I drank only water, by the way. I did. We got stuck at somewhere around hour 3 because I insisted on thinking like an engineer and saying, I need cars to go over the bridge. And Joel insisted on, I need the bridge to be up. And we didn't speak the same language. Please today consider we speak different languages. And we often need to try to figure out what the hell we mean. Okay, that's number one. We don't have our own set of language yet in security we all agree on. Just as it's thought for later on, not going into those hours. And on this, the original model here started with a risk-based model when we spoke about vulnerabilities, risks, threats. I insisted on putting trust in there as a basic building block of security, but eventually we brought it down to interactions and assets, just to show we can bring it to an abstract level. But then, when this became an atomic language, that was when I was kind of the problem, when I insisted, no, this is not good. It's not useful to me to have long formula that I can't really use day to day when you want to describe a whole process and life cycle. And I really hated those words because they don't necessarily lead one to the other across time. It can be any type of life cycle. We got stuck on that for 2 hours, just about the language. If we call it a life cycle now, that means it might be a circle, or it might be something else. And 10 years from now, all models will only look like a circle or a line or whatever. We just got stuck on that for 2 hours. But essentially, if it's not useful in the way of its mathematics, and I'm never going to use it if I'm a network operator or an analyst, or if not very useful because in the future I'm always going to think in a line, we created the atomic model, which is not perfect. It's far from our model. And we created a life cycle, and it worked together layered. And the reason I wanted to speak for a couple of minutes was to add to the difficulties we had in even discussing things and to show what we could potentially work through today. And emphasize what Joel said. When I was the problem, and they all called me an idiot for 2.5 hours, they still listened to me, and we reached something. But they did call me an idiot. So it was a combination of, Gary, what the hell do you want from us? Shut up! And we're going to listen to you until we reach something. And then the language issue of we all speak different languages. So today, when we break to different groups, we need to figure out what the end goal is. Can we make something abstract enough or something useful enough, something basic enough in security we can build upon? Or are we going to waste 5 hours or 5 long hours in discussing something that we'll learn from, have fun with, but eventually come up with nothing as far as results? And we've all been in many situations where we discussed problems of the internet and security for hours on end, felt good at ourselves, and then did it again the next year. So keep in mind, what's the result we want to reach? I think Sunil and April have something for that when we come back, or maybe they'll do it now. And on that note, thank you for listening. And April, it's yours.